For most of human history, the stars were silent witnesses. They gleamed above deserts, oceans, and forests, eternal in their stillness, untouched by the chaos of mortal life below. Ancient civilizations raised their eyes to them in wonder, carving patterns across the night sky. The Babylonians etched star charts onto clay tablets, aligning heaven with harvests and kings. To them, the constellations were not distant furnaces, but divine symbols, maps of fate, omens written in fire. The Egyptians aligned their pyramids to Orion, binding stone to starlight, convinced that the souls of pharaohs would rise to dwell among the constellations. For centuries, humanity imagined the heavens as a perfect, crystalline sphere, unchanging, eternal. The stars were thought to be pure, beyond the corruption of earth, guardians of order in a chaotic world. Yet even in this ancient awe lay a quiet suspicion, a sense that the lights above were not merely decoration, but kin, that some hidden connection tethered humanity to the stars. The Renaissance cracked open that mystery. In 1609, Galileo Galilei turned his telescope toward the night sky and saw what no human eyes had seen before. The Milky Way, once a misty ribbon, was revealed as a vast congregation of countless suns. Mountains rose upon the moon. Moons themselves circled Jupiter. The heavens were not flawless. They were alive, dynamic, restless. Galileo's telescope whispered a dangerous truth. The stars were not divine ornaments. They were worlds. Yet even then, the question of their substance remained. What were stars made of? Were they forged of the same matter as Earth, or were they woven from some celestial substance beyond human reach? For centuries, the question lingered unanswered, suspended between myth and speculation. The 19th century brought a new way of listening to the stars. Light itself became the messenger. Spectroscopy, the art of splitting starlight into its hidden rainbow, revealed fingerprints etched in color. When Isaac Newton had passed sunlight through a prism, he revealed a spectrum. But when Joseph Fraunhofer looked closer, he noticed something stranger. Dark lines cutting across the rainbow, tiny absences where certain wavelengths had been swallowed. These were not imperfections. They were cosmic signatures. Each element, hydrogen, sodium, iron, left its mark upon light, like notes on a cosmic score. By the dawn of the 20th century, astronomers realized that they could read these fingerprints in starlight itself. Every star became not just a distant point of fire, but a laboratory, its spectrum carrying the story of its chemistry across the abyss. For the first time, humanity could measure what the stars were made of. The results were shocking. Earth and sky were not divided realms. The very same elements found in terrestrial laboratories, iron, oxygen, carbon, appeared in the light of distant suns. The universe was not composed of some alien substance, but of the same building blocks that formed rocks, rivers, and life. The heavens and the earth were kin. And yet, this revelation carried a deeper surprise. In 1925, a young graduate student named Cecilia Payne, later Payne-Gaposchkin, made one of the most radical discoveries in the history of astronomy. Using spectroscopy, she showed that stars were not dominated by heavy elements like Earth. Instead, they were oceans of hydrogen and helium, with only traces of carbon, nitrogen, oxygen, and iron. Against the weight of authority, against the voices of established astronomers who rejected her conclusions, she insisted that the universe was not what it seemed. The stars were not mirrors of Earth. They were vast furnaces of hydrogen, alight with fusion, slowly transmuting the simplest atom into the seeds of complexity. Her work went largely unrecognized at first. In the silence of academic halls, her insight was ignored, her genius overlooked. Yet history would remember. It was Cecilia Payne who first revealed the true composition of the stars, unraveling a mystery that had endured for millennia. But even this truth carried another, deeper question. If stars were seas of hydrogen and helium, where then did the heavier elements come from? Where was the iron in blood, the calcium in bones, the carbon in every living cell? The answer, when it came, would change the way humanity understood itself. It was the British astrophysicist Fred Hoyle who illuminated the path. In the 1940s and 50s, Hoyle proposed that the heavier elements were not present from the beginning, but forged in the hearts of stars themselves. Within the crushing heat and pressure of stellar cores, hydrogen fused into helium, helium into carbon, carbon into oxygen. In the dying moments of massive stars, fusion leapt further, building heavier and heavier nuclei until iron marked the limit. And when these colossal stars collapsed, their deaths were cataclysmic supernovae, detonations so vast they outshone entire galaxies. In those violent deaths, shockwaves forced atoms together in violent unions, creating gold, uranium, and other rare heavy elements, scattering them into space. The cosmos itself was an alchemist. The universe had written the periodic table not in books, but in fire. Hoyle's insight transformed cosmology. The stars were not distant ornaments. They were furnaces, forges, creators. They were mothers of matter. The hydrogen born in the Big Bang was transmuted, generation by generation, into the rich complexity that made planets, oceans, forests, and mines. There is a moment in science when a simple truth carries infinite weight, when the implications spread like ripples across time. For humanity, that moment was the realization that the atoms of Earth and life were born in stars. The calcium of ancient bones, the iron that carries oxygen in blood, the carbon woven into DNA, all of it once was fired in a star's core, hurled outward in a final luminous breath. In that realization, the universe became more intimate and more mysterious. Humanity was no longer a stranger to the cosmos, but its child. Every glance upward was not just curiosity, but recognition. An ancient memory carried in atoms, whispering of a time before Earth, before oceans, before life. A time when everything that would one day breathe, and think, and dream, still burned in the heart of distant suns. The discovery was quiet, almost understated, buried in journals, debated in lectures. But its weight was immeasurable. Humanity had glimpsed its origin not in myth or legend, but in light itself. The stars were not merely above. The stars were within. For countless generations, the stars had seemed eternal. Their light, unwavering across the ages, rose and set with unbroken rhythm, as if the heavens were carved from some incorruptible perfection. Philosophers of Greece declared the stars fixed in crystalline spheres. The medieval sky was painted with the permanence of divine order. Earth was fragile, mortal, shifting, but the heavens were thought untouchable. The telescope had shattered the illusion of perfection, but not the belief in eternity. Even as the sciences advanced into the modern age, many clung to the image of stars as everlasting beacons, steady and unchanging. The idea that the night sky itself could die was unthinkable. And then the revelation came. The stars were not eternal. They were living entities, born, burning, and doomed to die. Like all living things, they carried a finite span of existence, their light not infinite but temporary. The cosmos was no longer a stage set with permanent lamps, but a restless, evolving theater. The shock was profound. At the heart of each star burned a furnace of unimaginable power. In their cores, hydrogen atoms fused into helium, releasing the energy that made the stars shine. For millions, even billions of years, this fire endured. But time was a predator and fuel was finite. The greater the star, the shorter its life. Some would fade gently into white dwarfs, their light dimming like the embers of a fire. Others, more massive, met their end in apocalyptic violence. Supernovae, stellar detonations bright enough to outshine entire galaxies. The heavens were not eternal guardians. They were mortal giants. The deeper shock was yet to come. For in the ashes of their destruction lay something even more extraordinary. When the colossal pressure of a collapsing star forced atoms together in its final moments, it forged the very elements of life. Carbon, the skeleton of all biology. Oxygen, the breath of living worlds. Iron, the blood of animals, the strength of mountains. Gold, rare and radiant. Uranium, hidden in Earth's crust. All of them born in the furnaces of dying stars, cast into the void as cosmic inheritance. The realization was staggering. The atoms in the human body, the iron coursing through veins, the calcium in bones, the carbon woven into DNA, were not born on Earth. They were minted in ancient stars, scattered across the galaxy in their final breaths, and gathered by gravity into the raw clay of planets. It was a truth so strange it bordered on heresy. For centuries, philosophy had placed humanity apart from the heavens. Earth was thought corruptible, temporary, imperfect. The stars were pure and eternal. And now, science revealed the opposite. The stars were mortal, fragile, and in their deaths lay the seeds of life itself. The sacred separation between heaven and earth had dissolved. The human body, once thought to belong only to soil and water, now carried within it the ashes of dead stars. For some, the revelation was terrifying. It stripped away the comforting illusion of eternal heavens. It revealed a cosmos that was not static but restless, driven by fire and collapse. For others, it was exhilarating. It meant that humanity was not a stranger to the universe, but its child. It meant that life was not an accident of Earth alone, but the flowering of cosmic processes as old as time. The shock reverberated across science. In lectures and journals, astronomers spoke of nucleosynthesis, the creation of elements in stars. The periodic table itself transformed from a list of earthly curiosities into a cosmic history, each element a chapter written in fire. Hydrogen and helium born in the first moments after the Big Bang. Carbon, nitrogen, and oxygen forged in the steady cores of stars. Iron, nickel, and beyond born in stellar collapse. The rarest elements, such as gold and platinum, flung into space by the collisions of neutron stars. The universe was no longer just vast in size, but rich in genealogy. Stephen Hawking, reflecting on the revelation, described the stars as crucibles of existence. To him, they were not remote ornaments but engines of transformation, weaving the tapestry of complexity from the fabric of simplicity. In the violence of collapse and the brilliance of explosion, the cosmos revealed its dual nature. Destructive, yet profoundly creative. From death came the possibility of life. This was the paradox that shook the human view of reality. The universe was not eternal stasis but eternal change. Its beauty lay not in permanence, but in impermanence. The stars were not eternal gods, but ancestors, living and dying so that planets and beings might arise. And with this realization came an unsettling awareness. If the stars themselves could perish, if even suns were mortal, then what of everything else? Galaxies would burn out. The cosmos itself, in its farthest future, would grow cold and dark. The permanence humanity once sought in the heavens dissolved into the inevitability of time. Yet even in this shock there was wonder. The iron in every breath, the calcium in every heartbeat, the oxygen that sustains each flame, these were gifts of ancient suns. Humanity did not stand apart from the cosmos, but was written into its story. The body was not made merely of Earth, but of galaxies. The scientific shock of stellar mortality was not only intellectual. It was existential. It forced humanity to see itself anew, not as subjects beneath eternal stars, but as children of their fire. Every sunrise became a reminder of nuclear fusion in action. Every heartbeat an echo of supernovae long past. This was the revelation that ended the Earth-centric view of life and the heavens. The stars were not eternal, yet in their deaths, they gave birth to the possibility of consciousness, to eyes that could look back at them with recognition. In that recognition lies the most unsettling truth of all. The universe is not indifferent to life. It created the conditions for it, again and again in every dying star. Humanity is not alien to the cosmos. Humanity is the cosmos made conscious. The revelation that stars were mortal did not end the mystery. It deepened it. For if stars could live and die, if their deaths created the elements of life, then what precisely unfolded within their hearts? What secret fires transformed the simplest atom into the architecture of worlds? The answer lay in a process so powerful, so precise, that it would come to define the life story of the universe itself: nuclear fusion. At the core of every star, gravity wields its relentless hand. It pulls inward with such force that hydrogen atoms, normally repelling one another with invisible walls of electric charge, are pressed together until they merge. In this union, two protons fuse, transforming into helium, and in the act of becoming, release a flood of energy. This light, this heat, this radiant brilliance, is the heartbeat of a star. In stars like the Sun, this simple alchemy, hydrogen to helium, endures for billions of years, an endless rhythm of creation. But as fuel dwindles, the fire grows more complex. Temperatures rise, pressures intensify, and helium itself becomes the seed for new transformations. Carbon is born. Oxygen follows. Neon, magnesium, silicon, each step a rung in the ladder of cosmic evolution. The periodic table, once a static chart pinned to the walls of classrooms, becomes something far greater, a cosmic map. Each element tells the story of its birth, each number a timestamp of stellar history. Hydrogen forged in the Big Bang. Carbon crafted in the cores of red giants. Gold and uranium, rarities reserved for cataclysms. The table is not human invention, it is a record of the universe itself. Yet even this stellar chemistry has limits. Fusion can climb only so high. When iron is formed in a star's heart, the chain halts. Unlike lighter elements, iron does not release energy when fused, it consumes it. The balance between gravity pulling inward and fusion pushing outward collapses. The star, once a radiant giant, falters. And in that faltering, the most violent spectacles in the cosmos are born. When a massive star dies, its core implodes. In a fraction of a second, gravity crushes matter with inconceivable force, shattering atomic structures. Protons and electrons fuse into neutrons, releasing a flood of neutrinos that blast outward like a silent scream. The star's outer layers, unable to withstand the violence, are hurled into space in a supernova explosion, brighter than billions of suns combined. It is here, in the chaos of collapse, that the universe forges its rarest treasures. Gold, platinum, uranium, atoms too heavy for ordinary fusion, are hammered together in the crucible of destruction. Shockwaves force nuclei into unions otherwise impossible, scattering them into the galaxy. Worlds are seeded not only with life's carbon, but with the glitter of ornaments, the fuel of reactors, the bones of future technology. But supernovae are not alone in their alchemy. When two neutron stars, remnants of massive stellar deaths, collide, they unleash torrents of gravitational waves and gamma-ray bursts, tearing space-time itself with their violence. In these collisions, the heaviest elements are forged in staggering abundance. In 2017, astronomers witnessed such an event for the first time, as detectors on Earth registered both the tremor of spacetime and the flash of light from colliding neutron stars. In that singular cosmic instant, humanity saw the birthplace of gold. These discoveries did not come from speculation alone. They were carved from patient observation, from instruments built to listen to the faintest whispers of the universe. Spectroscopy revealed the fingerprints of elements scattered across starlight. Through it, astronomers could trace hydrogen and helium, but also the heavier elements sprinkled into the cosmos. Particle detectors, buried deep beneath mountains and oceans, waited in silence for neutrinos, the ghost-like particles released in supernovae. In 1987, when a star in the Large Magellanic Cloud collapsed, detectors on Earth caught the faint arrival of neutrinos, confirming what theory had long suggested, that dying stars broadcast their agony across light years. And then came the observatories of gravitational waves, LIGO and Virgo, measuring distortions in spacetime itself, allowing humanity to hear, for the first time, the collisions of neutron stars, the very events that seeded the universe with its rarest materials. Each new layer of observation revealed the stars not as distant ornaments, but as engines of creation. Their light was not merely illumination. It was the visible sign of matter being born, transformed, and prepared for the emergence of worlds. In laboratories and lecture halls, the implications spread. The stars were no longer seen as mere celestial fires. They were architects. The cosmos itself was alive with the rhythm of transformation. The atoms of life, the treasures of civilizations, the fuel of planets, all owed their existence to the restless cycle of stellar birth and death. The deeper humanity looked, the more intimate the connection became. The body itself was a living archive of stellar history. The the carbon of every breath, the oxygen of every heartbeat, the iron that binds oxygen to blood, each was a message from a star, a relic of cosmic fire. And so, what began as a question of astronomy became something greater, a redefinition of identity. To know the stars was to know the self. To trace their alchemy was to trace the story of matter into the very structure of life. The stars were not only distant lights, they were engines of existence, and in their cycles of birth, fire, and collapse, they whispered the story of everything humanity has ever known. In the quiet hours of the universe, a question stirs with unsettling beauty. If our bodies are made of stars, could life itself, this fragile spark of awareness, have stellar origins? The idea is not born of poetry alone, but of science, etched into the very dust that drifts between galaxies. For decades, the theory of panspermia has lingered on the edge of mainstream thought, an audacious possibility that life's seeds were never confined to Earth. Perhaps they came riding on frozen comets, hidden deep within asteroids, or drifting silently on the breath of stellar winds. If true, then the story of life is not planetary, but cosmic, a tale carried across billions of years and unimaginable distances. Astronomers turn their gaze toward molecular clouds, the vast nurseries of the galaxy. These cold, shadowed regions, dense with gas and dust, give birth not only to stars but to chemistry. Within them, telescopes have revealed something astonishing: the fingerprints of complex organic molecules, scattered across the dark like a hidden script. Methanol, formaldehyde, even amino acids, the very precursors of proteins, have been detected floating in the void. In 2016, the Atacama Large Millimeter Array, perched high in the Chilean desert, confirmed methyl isocyanate, an ingredient for peptide bonds, drifting around a young star system 400 light-years away. Other observations have traced glycine, the simplest amino acid, in the tail of comets within our own solar system. The implication is staggering. The cosmos is not barren, but fertile. It does not merely forge stars and worlds, it weaves chemistry that leans toward biology. And so, the mystery deepens. Did Earth truly create life from its own oceans and rocks? Or did it merely assemble a puzzle whose pieces had been cast across the stars long before our planet was born? Here lies a profound paradox. Are we children of Earth, or children of the stars? To claim we are Earthborn is to believe life is a local miracle, sparked by the right mix of water, minerals, and lightning strikes. But to claim we are starborn is to accept that life may be universal, seated wherever conditions allow, waiting for time to awaken it. Between these two visions lies one of science's greatest enigmas. For if panspermia is true, then the boundary between biology and astronomy dissolves. Every comet that streaks across the sky, every meteorite that burns in the atmosphere, may carry whispers of kinship, fossils of chemistry older than Earth itself. And if life was scattered through space, then its origins stretch back not 4 billion years, but perhaps 10, to an era when the Milky Way itself was young, and the first heavy elements forged in supernovae had just begun to seed the void. It is a haunting thought that when we look upward into the night, we are not only gazing into the past, but into the ancestral cradle of life itself. In the vast silence of the universe, stars burn as both architects and storytellers. They are the engines of chemistry, the forges of matter, and perhaps, if speculation dares, midwives of life itself. Yet the mystery lingers. Are stars merely indifferent furnaces, or are they the quiet authors of existence? Across decades, scientists, philosophers, and dreamers have traced the lines between stellar fire and the fragile phenomenon called life. One school of thought gazes directly into stellar chemistry. The stellar origin theory of life suggests that life is not an accident upon Earth's soil, but the natural byproduct of stellar processes. Within the nuclear hearts of stars, simple atoms of hydrogen and helium transmute into heavier elements: carbon, oxygen, nitrogen, iron. These are not just elements of geology. They are the skeletons of biology. Every strand of DNA, every protein folded within a cell, every pulse of oxygen in a lung is, at its root, the lingering echo of stellar fusion. If life requires such ingredients, then life is not alien to the stars. It is their inheritance. Yet not all ideas remain within the closed cradle of Earth. In the 1970s, the astrophysicist Fred Hoyle and his collaborator Chandra Wickramasinghe advanced a daring vision: panspermia. According to their hypothesis, the seeds of life may drift across space, carried upon comets, asteroids, and interstellar dust. They argued that life's building blocks, or even primitive microbes, might survive the long cold voyage between worlds. It was a proposal met with controversy, for it blurs the line between origin and arrival. If Earth's first spark came from beyond, then life is not a local accident. It is a galactic traveler, scattered by stars, awaiting the right soil to take root. Modern evidence reveals complex organic molecules embedded in interstellar clouds and amino acids discovered on meteorites fallen to Earth. The controversy remains, but the question persists. Are we children of Earth, or children of the cosmos itself? Beyond the chemistry of stars lies a wider canvas: cosmic inflation and the specter of the multiverse. According to modern cosmology, our universe swelled from an infinitesimal point, expanding in a breathless instant of inflation. Yet some theories suggest this was not singular, but one bubble in an endless froth of universes. If stars form in not one cosmos but countless, then the question of life becomes magnified. In a sea of infinite stars, is life not just possible, but inevitable? Perhaps even repeated in uncountable variations. Some universes may be barren, tuned to silence. Others may burn too hot or collapse too quickly. Yet somewhere, conditions align. Stars ignite, chemistry flows, and consciousness awakens to ask its own origin. It is a thought both humbling and vast, that our existence may be one expression among infinite reflections, written into the very structure of cosmic possibility. Still deeper lies the strangeness of quantum theory. At the foundation of matter, quantum fields govern the dance of particles. The electron's charge, the proton's mass, the strength of the strong nuclear force, each number is fixed with astonishing precision. Were any slightly altered, atoms could not form, stars could not burn, and chemistry could not unfold. Some physicists describe this as fine-tuning, a precarious balance that permits the existence of stellar alchemy. If true, then the universe is not just hospitable to stars, it is constructed for them. And through stars, life gains the stage upon which to emerge. Quantum physics whispers of a cosmos where the conditions for life are not accidental, but woven into the mathematics of reality itself. Above the quantum fields stretches the geometry of spacetime. Einstein's theory of relativity reveals how mass bends the fabric of existence, guiding planets in their orbits and stars in their cycles of birth and death. Without spacetime's curvature, stars could not collapse into white dwarfs, neutron stars, or black holes. And without their explosive deaths, supernovae scattering elements across the void, the ingredients of life would never be spread into new worlds. Relativity is not only the language of gravity, it is the silent script upon which stars perform their drama. It allows matter to collapse, explode, recycle, and in this cosmic recycling lies the possibility of living worlds. Each of these theories, stellar chemistry, panspermia, cosmic inflation, quantum fine-tuning, and relativity, extends the same haunting inquiry. Are stars merely makers of matter, or makers of meaning? Perhaps the story of life is not separate from the story of stars, but a continuation. The heat of fusion, the violence of supernovae, the patient drift of interstellar dust, all may converge into the fragile phenomenon of consciousness. And if so, then every glance at the night sky is not only a look outward, but inward. The stars above are the same furnaces that gave rise to blood, bone, thought, and memory. The same crucibles that shaped galaxies have also shaped the human heart. Across light years and eons, the question remains open, echoing through science and philosophy alike. Did the universe ignite stars so that life might ask, why? In the silence of the cosmic ocean, humanity has learned to build its own eyes. Eyes so vast they span mountaintops, so delicate they can catch whispers of starlight born billions of years ago. And through them, the universe reveals not just its beauty, but its secrets, slowly, carefully, like a story unfolding across eons. The James Webb Space Telescope drifts 1 million miles from Earth, suspended at the edge of darkness. Its golden mirrors, each carved with atomic precision, open windows into stellar nurseries, the hidden workshops of creation. Here, clouds of hydrogen collapse under gravity's patient hand, igniting furnaces that will burn for billions of years. Webb does not see with ordinary sight. It peers in infrared, tracing the heat of stars before they are born, uncovering newborn suns swaddled in dust. In its gaze, astronomers have watched cosmic cradles where planets begin to gather, and chemical fingerprints, carbon, oxygen, water vapor, mark the first ingredients of habitability. But Webb is not alone. On the high deserts of Chile, at 5,000 meters above sea level, another sentinel waits. The Atacama Large Millimeter/Submillimeter Array, ALMA, listens to wavelengths invisible to the human eye. Its 66 antennas move in perfect choreography, catching the faint radio glow from disks of gas and dust encircling young stars. Within these disks, ALMA has mapped spirals of dust where worlds are assembling. It has even traced the spectral shadows of complex organic molecules, methanol, acetaldehyde, and cyanides, seeds of chemistry that may one day awaken as biology. In these signals, faint as breath on glass, is a question that science has yet to answer. Are these the universal preludes to life, or only echoes of chance? Far below Earth's surface, another kind of experiment attempts to reach backward in time. In giant particle colliders, protons smash together at energies mirroring the universe's first seconds. From the debris, fleeting particles emerge, quarks, bosons, neutrinos, ghosts of a moment when matter itself was raw and unformed. These collisions recreate the violence that once forged the nuclei of atoms, the same nuclei that stars would later stitch into heavier elements. By probing these reactions, physicists seek to understand how the cosmos first seeded itself with the materials that chemistry, and perhaps biology, would inherit. Yet, some messengers cannot be created in laboratories. They must be caught as they pass through Earth itself. Neutrinos, tiny particles with no charge and almost no mass, stream through the planet by the trillions every second, unnoticed. They are born in nuclear furnaces, in supernovae, and in the death throes of collapsing stars. To detect them, observatories are built in the most unlikely places. Deep under Antarctic ice, beneath mountains, or at the bottom of lakes. Here, arrays of sensors wait for a rare spark of interaction, a brief blue flash that reveals the passage of one ghostly traveler. Each captured neutrino is a message in a bottle from across the cosmos, carrying news of processes hidden from ordinary light. In their patterns, astrophysicists read the heartbeat of dying stars and the rhythm of galaxies themselves. Still, the search is not only outward, but also close to home. Astrobiology missions spread across the solar system like a patient network of scouts. The Mars rovers crawl over ancient riverbeds, analyzing rocks for trapped organic compounds. The upcoming Europa Clipper will fly through the plumes of Jupiter's frozen moon, tasting their chemistry for traces of habitability. Saturn's Enceladus, with its geysers of salty water, tempts scientists with the possibility of subsurface oceans rich in potential energy sources. Meanwhile, surveys of exoplanets, using both ground-based telescopes and space missions like TESS, continue to catalog alien worlds in the thousands. Some lie in the habitable zones of their stars, where liquid water could exist. Others show signs of atmospheres, with tantalizing hints of biosignatures yet to be confirmed. Beneath all these endeavors runs a single thread, the attempt to trace the chemical pathways that lead from cosmic dust to life itself. In laboratories, researchers simulate interstellar conditions, chilling simple molecules to near absolute zero and bathing them in ultraviolet radiation. Out of these experiments emerge amino acids, nucleobases, and sugars, the alphabet of biology. Scientists call this prebiotic chemistry, a bridge of possibility from physics to life. But the bridge is incomplete. The leap from molecules to cells remains one of the great mysteries. Did life spark only once on Earth? Or does the cosmos carry within it a universal recipe, waiting to be stirred wherever conditions allow. Each telescope, each collider, each probe is a fragment of a puzzle scattered across time and space. Together, they form a map of possibility. They whisper of a universe not sterile, but fertile, not silent, but humming with the quiet persistence of chemistry striving toward complexity. And yet, no instrument has yet captured the final proof, that elusive moment when inert matter awakens, when molecules cross the threshold into life. For now, humanity stands on the shore, listening to the waves of data wash in from the deep. What they reveal is both humbling and exhilarating, that the universe is more than vast emptiness. It is a canvas where nature experiments endlessly, with stars as kills, with dust as clay, with time as its patient sculptor. In the quiet of existence, a truth rests beneath every breath, every heartbeat, every fleeting thought. Humanity is made of stars. The calcium in our bones, the iron in our blood, the carbon that shapes our flesh. All were born in furnaces billions of years old, scattered by supernovae across a silent universe. Each atom carries within it a memory of light, of ancient fire, of a time when our matter did not think, did not feel, did not dream. Yet now those same atoms gaze upward. The universe has given rise to a form of awareness that can look back at the heavens from which it came. Consciousness, an emergent whisper born from stardust, has turned the cosmos into both creator and witness. Humanity is the universe contemplating itself. If this is true, then Earth is not our birthplace, but our vessel. A fragile cradle carrying stellar children across the ocean of time. The soil beneath our feet, the air we breathe, even the oceans that shimmer under sunlight. All of it forged from the debris of dying stars. To call this planet home is to acknowledge not only our dependence on it, but the cosmic journey that made its existence possible. Earth is not the origin, but the gathering place, a temporary harbor for starborn wanderers. The cycle of life and death that shapes the universe mirrors our own fragile mortality. Stars are born, they live, they burn, and they die, sometimes gently, sometimes in cataclysmic fire. From their deaths, new stars emerge. From their remnants, planets form. From their debris, living beings awaken. The universe is a vast cycle of renewal, and in the smallest reflection, so are we. Each generation gives rise to the next, each death returning its matter to the soil, to the wind, to the endless chain of being. Humanity's story is not separate from the stars. It is the same story, written in different scales of time. Perhaps that is why every glance upward feels so heavy with longing. When the human eye meets the night sky, it is not only wonder it feels, but remembrance. A recognition buried deep within the atoms of our bodies, a memory older than life itself. The stars we see are not strangers. They are kin. To gaze upon them is to sense our origin. It is as though our bodies remember the fire from which they were born, and our minds, though fragile and brief, cannot help but reach toward that infinite past. Science tells us that one day the Earth will no longer sustain us. The sun, too, is mortal. In 5 billion years, its fuel will fade, its light will swell into a red giant, and its warmth will consume the very planet that nurtured life. Long before then, perhaps, humanity will have carried its consciousness elsewhere, if it survives at all. Like seeds carried on solar winds, civilizations may scatter, searching for new worlds to call home. And if they do, the story will not be one of exile, but of return. For to leave Earth is not to abandon our birthplace, but to continue the journey that began in the stars. What, then, is consciousness but a way for the cosmos to preserve itself? To remember, to create, to dream of futures yet unwritten? Civilizations rise and fall, but thought leaves echoes. Stories carved into stone, signals drifting across interstellar distances, machines that may one day outlast their makers. Each step, each discovery, each fragile attempt to understand is another thread woven into the fabric of cosmic memory. And yet, the mystery remains unresolved. What is the purpose of this awareness? Why should matter, arranged in such delicate patterns, awaken to its own existence? Science traces the mechanics, but not the meaning. The universe is silent on the question of why. Perhaps there is no answer, only the act of being, only the experience of seeing, thinking, remembering. But perhaps the very search for meaning is itself the answer. A flame passed down through generations, an echo of stars yearning to know themselves. One day, humanity may scatter into the galaxy. It may build vessels that carry minds farther than the light of our sun. It may shape machines that inherit the duty of thought. Or perhaps, in some distant future, we may learn not only to scatter as stardust, but to return as stories, as civilizations, as conscious fragments completing the circle of origin. If that day comes, it will not be a departure, but a homecoming. For the stars are not only behind us, they are ahead. They are our past and our future, our ashes and our destination. And so the story closes where it began, with a question suspended in silence. What if every life, every thought, every fragile flicker of consciousness is not merely passing through the cosmos, but is the cosmos itself, searching, remembering, returning? What if, one day, we do not just return to the stars as dust scattered by time, but as minds, as civilizations, as stories, completing the circle of our true origin?